Welcome to the Deep Dive. This is where we take your sources, dig in, and really pull out the core insights for you. A shortcut to getting up to speed.
That's the idea.
So today we're plunging into something, well, completely new. It's called Space Ordinals, a brand new number system.
And there's a board game involved, too.
Exactly. A board game designed specifically to launch these space ordinals into the world. So our mission, really, is to understand this fresh take on numbers.
Something as basic as numbers, yeah.
And this surprisingly innovative game built around them. It's all based on an interview with the inventor.
Okay.
And yeah, get this, the person behind Space Ordinals, they also call them universal numbers, wants to offer them completely free.
Free. That's
Yeah.
interesting.
And they've got a background, apparently, with NASA. Their way to get the ball rolling, making a board game with some interns.
Wow. Okay, that's quite an approach. Not just inventing something potentially huge, but giving it away and building a promotional tool, a game
Yeah.
with interns.
Right. It suggests, a real belief in the idea itself.
Definitely. Okay, so let's unpack this. Space ordinals. What are they, fundamentally?
Okay, so in essence, they're a new set of visual symbols. Graphic symbols meant to replace our standard numerals, 0 through 9.
Replace them entirely.
Well, the inventor sees them being really useful in space, hence the name, but also having practical uses right here on Earth. And to kind of explain why someone would invent new numbers, the inventor uses the analogy of Roman numerals.
Okay, yeah, I can picture those. Clocks, Super Bowls.
Exactly. We all know them. They worked fine for, like, ordering things, sequence, King Henry VIII, that kind of thing.
But not for complex math.
Right. They get really awkward for big numbers or, serious calculations.
So that comparison highlights limitations. But our current numbers, the Indo-Arabic ones we use every day, they're pretty good for math. So what's the problem with them that space ordinals fix?
Ah, good question. And the inventor points out a few key issues. First off, orientation.
Orientation, you mean like...
Like 6 and 9. Flip one over, it looks just like the other.
Ah, right. I see that.
The inventor even told this hypothetical story, thankfully hypothetical, about a house number, say 6008, being installed upside down.
Oh, no. It would read 809.
Exactly. Imagine the mail delivery chaos. It's a simple example, but it shows the potential for confusion.
Okay, that makes sense. What else?
Well, there's also the risk of errors or even deliberate changes, tampering.
How so?
Think about dropping a digit or accidentally adding a 0 or an ink smudge turning a 3 into an 8, stuff like that.
Right, especially where accuracy is critical, like maybe financial data or scientific measurement.
Precisely. Or as the inventor really stresses, in space. There's no natural up or down out there to give you context. 6008 could easily look like 809 depending on how you approach it.
Okay, I'm starting to see the motivation, that lack of inherent orientation and the potential for alteration. In high-stakes situations like space travel or communication, that could be a real weakness.
Exactly. And that brings us to the big advantages of space ordinals. First, they're designed so you can read them correctly no matter the orientation. Upside down, sideways, doesn't matter.
No more 6 versus 9 issues.
Nope. Plus, they have built-in security features. It's much harder to, say, sneakily add a digit or change one into another.
Built-in security.
Interesting.
But here's the really cool part, I think. The inventor insists these aren't some complex, abstract symbols you have to memorize. They're based on simple geometry.
Geometry.
Yeah, the idea is they're intuitive. So intuitive that a 3-year-old from Mississippi or, an alien from Alpha Centauri could grasp them. No language needed, no cultural background. Universal.
Wow, okay, that's a bold claim. Basing it on geometry for universal understanding.
That's a fascinating concept. It tackles communication barriers at a really fundamental level.
Totally. So what do they actually look like?
Yeah, let's get visual.
Okay, picture a circle. That's the basic shape, the outer boundary for every digit, 0 to 9.
A circle for each one. Got it.
Inside that circle, there are straight lines, line segments, and the number of lines equals the value of the digit.
Ah, okay, so 1 would be...
A circle with 1 straight line inside.
And 2?
2 straight lines, kind of like a Roman numeral 2, but inside the circle.
Okay.
3 lines forming a triangle inside the circle.
4.
4 lines making a square shape.
Makes sense. 5?
5 lines. The description is like a Y-shaped mirrored, so it touches the circle in 5 places.
Okay.
6 lines. 6 lines. It looks like a triangle, but with extra lines. It's sort of like arms coming off the points.
7?
7 lines. A small square inside with 3 extra lines, like arms reaching out.
Getting complex.
8 lines. So it's like 2 diamond shapes stacked vertically, sort of a blocky 8-figure.
And 9.
9 lines. A triangle again, but this time with lines extending downwards from the corners, like legs.
Okay, I think I can picture those. What about 0?
0 is special. It's a circle inside the main circle. No lines at all.
Circle in a circle, 0 lines. That fits the pattern. That direct link number of lines equals value seems very direct. Easy to learn, potentially.
That's the idea. Now, for bigger numbers, like say 1, 2, and 3,
How does that work?
you just string the symbols together. The symbol for 1, then the symbol for 2, then the symbol for 3, side by side.
Okay, simple enough, but how do you know which end is the start? Like, is it 123 or 321?
Ah, good point. There's a rule for that. The most significant digit, the one on the far left, like the one in 123, gets emphasized.
Ow.
Could be bolder or bigger or maybe different color. But the standard way, the inventor says, is to rotate that leftmost digit by 45 degrees.
A 45-degree tilt. Okay, a clear visual cue.
And there's another rotation thing for security. Remember the anti-tampering idea?
Yeah.
The very last digit in any number sequence is always rotated 90 degrees.
90 degrees. Why?
It acts as a clear end marker. If someone tried to tack on an extra digit at the end, it wouldn't have that 90-degree rotation, making the tampering obvious.
Clever. So leftmost is tilted 45, rightmost is tilted 90?
You got it. And one more thing. Spacing. How close the symbols are tells you if they're part of the same number or separate numbers.
Okay.
They can touch or have a small gap. Up to half their diameter still counts as one number. But if the gap is as wide as the symbol itself or wider,
It means a new number starts.
exactly. It's a really thought-out system, isn't it?
Yeah.
Covers orientation, security, multi-digit representation, separation.
It really does. The visual cues for significance, the end marker rotation for security, it addresses potential problems right in the symbol design itself. Quite elegant.
So, okay, you've got this potentially, revolutionary number system. How do you get people to actually use it?
Yeah. Adoption is always the challenge for new standards.
Well, the inventor and their interns came up with a board game,
Ah, the board game.
right?
Just to promote the ordinals.
That was a big part of it, yeah. But not the only goal. They actually had several things in mind.
Like what?
Well, they wanted to give the interns real hands-on experience, product development, manufacturing, the whole process.
That's valuable.
And they also wanted to design a game where winning doesn't mean someone else has to lose. More collaborative.
Okay, that's less common in board games.
And maybe the most surprising goal.
Yeah.
They wanted a game that actually encourages good behavior, positive interactions between players.
Wow. Okay. Promoting numbers, teaching manufacturing, cooperative play, and encouraging niceness. That's ambitious for one little board game.
It is. And the game design changed quite a bit along the way.
Oh.
Early versions were apparently very strategic,
Hmm.
but they found experienced players could just dominate.
Yeah, that can happen. Not fun for newcomers.
Right. So they split the gameplay into levels. You can choose a simpler or more complex version depending on who's playing.
Smart. Accommodates different experiences.
They also added something called twists.
Twists.
Yeah, like minor rule changes or complications. The interesting part is the players decide together whether to add a twist or not. Adds a bit of risk-reward, player agency.
Okay, I like that. Players tailoring the challenge.
And this is really interesting. They built in a feedback system. It's designed to encourage players to help each other, give tips, make sure nobody gets totally lost or left behind.
How does that work?
They didn't go into exact mechanics in the interview, but they even mentioned having a way to gently discourage players who get too dominant or, showboat.
Huh. A mechanism to curb arrogance in a game? That is unusual.
Yeah. And they simplified scoring. At first, every piece you played scored points. Now only completed sequences score. Makes it cleaner.
Focuses the objective.
And to make setup and turns easier, they put all the game pieces, the space ordinal tiles, presumably, into a bag. They call it the nebula. You draw from the bag.
Nebula. Okay, so there's a theme emerging.
Totally. Since the core components are space ordinals, a space theme felt natural. The bag is the nebula.
Where you draw pieces from, like stars forming.
Exactly. The area where you play the pieces is called the void.
Makes sense.
The sequences you're trying to build are called constellations. And the unexpected things, maybe from those twists, are called cosmic events.
Fits perfectly. But they said the core mechanic is themable.
Yeah, the basic idea of drawing pieces and placing them in sequences. They designed it so you could slap almost any theme onto that framework. Animals, history, whatever.
Interesting. So the core design goals were?
First, Super accessible. The only skill you need is basic counting. Ties right back to the intuitive idea of space ordinals.
Low barrier to entry. Good.
Second, no player elimination. Everyone plays the whole game, stays involved.
Always a plus, especially for families or casual groups.
Third, like we said, easily re-themable. They hope others might run with the basic mechanics, maybe create a new genre of game.
Open source game mechanics, almost.
Kind of. And fourth, that intern experience goal, making sure it was a project where they could learn about actually creating and manufacturing a physical product within skills they could master relatively quickly.
A very holistic approach to the project. Game design, education, new number system promotion.
So what makes the game stand out? The inventor joked it's ready for intergalactic dominance because numbers and geometry are universal.
Maybe a slight exaggeration.
Maybe. But practically, it really discourages that beat the other player's mentality. It's set up so everyone can potentially win, maybe even by helping each other.
A cooperative or semi-cooperative feel, then.
Seems like it. And there's potential to easily integrate educational stuff. Imagine versions teaching math facts or history dates using the sequence mechanic.
Yeah, I can see that. The sequence building lends itself to that.
And it's designed for remixing, retheming, extending by other people.
Very community-focused. Did they talk about playtesting?
Oh, yeah. Lots of it. Started internally, then they wrote down rules, revised them over and over based on feedback.
Standard process, yeah.
Then beta testing with adults and kids to get different perspectives.
Crucial to test with the actual target audiences, or a range of them.
What were the big challenges in development?
Besides inventing a number system and designing a cooperative game.
Well, related to the game production, they really wanted to figure out what they called micro-manufacturing methods, M-cubed.
M-cubed. What's that?
Basically, ways for ordinary people, maybe small groups or individuals, to actually make the game themselves. By hand, low cost, low capital investment.
Sort of like a maker movement approach to board games.
Yeah.
Decentralized production.
Exactly. Which tied into cost constraints. They were aiming to get the cost of the game pieces, there are 70 in the first version, down to under 10 cents each.
Wow, that's tight. Material choices, manufacturing process, dictates a lot.
For sure. And even the box design was limited by wanting to use standard, cheap printer paper, letter-sized.
Resourcefulness born from constraint happens a lot in design.
How did they handle balance and fairness in the game itself?
Beyond just a cooperative goal.
Yeah. Well, they deliberately avoided common negative mechanics. No kicking players out, no stealing resources from each other.
Keeping it positive.
And they added team points. Points players can actually give to each other.
Leave points away. For what?
For being helpful, maybe giving good advice, contributing positively. It's that anti-showboating, pro-teamwork mechanism again.
That's fascinating. Using points as a social reward system within the game addresses the arrogant expert player problem, potentially.
Right. And while there is some luck, drawing pieces from the nebula
There's
bat,
element of chance.
success mostly comes down to making smart choices with what you draw, seeing opportunities to build sequences.
So chance provides variability, but decisions matter more. Standard good game design.
And the theme, the space stuff, we touched on it, but it really grew directly out of using the space ordinals.
The components suggested the theme.
Yeah. Nebula, void, constellations, and the cosmic events at higher levels were apparently inspired by real space phenomena.
Nice thematic integration. So after all this, the ordinals, the game, the interns, what was the inventor most proud of?
You might think the number system, right? Or the game.
That would be logical.
Nope. It was the interns. Their learning, their growth, seeing them become, in the inventor's words, professional game designers through the process.
That puts the focus back on the educational aspect, the human element. That's quite telling.
Yeah. So what's the hope for the future?
Where do they see this going?
Well, ideally, local makers pick up the game design, adapt it, maybe using those M-cubed methods.
The decentralized production idea.
Yeah, with maybe some royalties going to support education in Liberia, which was mentioned as a specific cause.
Okay. And the ordinals themselves.
Hope is that other designers start using space ordinals in their games or other creations, spread the system organically.
Let the idea propagate.
And yes, that intergalactic tournament idea came up again, though realistically probably virtual at first.
Probably wise. Booking travel between star systems is tricky.
Right. And maybe even a book or a documentary about the whole project someday.
It's certainly a unique story.
So wrapping up this deep dive, it's Genuinely intriguing, isn't it? This idea of space ordinals as a potentially universal number language.
And the very collaborative, education-focused board game created to shepherd them into existence. It's a different way of thinking about innovation.
Yeah, it's a really cool look at that intersection of like technology, education, design, and just play.
Definitely.
And it really makes you think. We talked about the limitations of our current numerals, something we take completely for granted.
Yeah, the orientation, the security,
Yeah.
things you don't normally consider.
So the thought to leave you with is, what other fundamental systems, things we assume are just the way things are, might actually be ready for a complete radical rethink?